All right, good afternoon. Um, it's my first time in Mexico City, so I'm very excited to be here with you. I will speak about knowledge graph in action. Because there is the word action, I have 0 slide, so it's everything live demo. Maybe we can start with what are knowledge graphs, which is actually a very controversial topic because nobody knows what are knowledge graphs. We all have our own explanation of what is a knowledge graph. So if you go to Wikipedia, you have one explanation. Google has its own explanation, and every AI company has an explanation about what is a knowledge graph. So I will give my explanation of a knowledge graph. It's actually the definition of your business, your domain, the problems you have, and the solutions that you're trying to put in place to solve those problems. And to me, a graph is a good representation to expose domain, solutions, and problems. And the fundamental aspect of expressing a domain for us is a schema. Of course, you heard that Neo4j is schemaless, but your domain can have a schema, right? So you have to express, actually, what you are, what you know, what you want to know, etc. So for the demonstration today, I will take some news from the web, like here, BPC News, for example. But it doesn't matter, it can be any data, right? So it's just a demonstration. So I will express what is my domain, what I know. So I will take those news, and actually my domain now is a node, news. All right? I can say that this node has an ID, for example, has a title, and has some text. For the sake of beauty, I can even put an icon on this node. Oh. And a color. So up to now, this is my domain, all right? And I will create a knowledge graph based on this domain, based on my schema. So I create a new knowledge graph, let's say demo Mexico. The schema I'm going to use is the demo schema. And I will import some data. I will give a set of news that I downloaded from the internet. Because I'm doing big data, I will import 2 news. So I imported on my file system some data. Actually, if you want to know what it looks like, it's a JSON file. So I scraped the website, put the text into JSON, and I uploaded those files to the system. Okay? Then actually I want to take those JSONs and transform this into a graph structure. Very, very complicated graph structure because we have only one node, right? So I have my news here. So I want to say that the URL of the article becomes my ID because generally it is unique. It's not always the case, but because sometimes you have those parameters, very fancy. The title becomes the title, and the text becomes the text. And now, I will import my data. So you can see on a big data set, it's going pretty fast, right? So, and now this is actually our knowledge graph. 2 news. But this is very, very sad, right? Because those 2 nodes even are not connected. There is no relationship. It's a knowledge graph, right? A node is a graph. but there is no relationship. So what can we do actually to extend the knowledge that we have about the data? We know it is textual data. So we know there are things inside the text that we are interested in, right? Persons, organizations, locations, names of diseases, things like this. So we want to extend the schema, the domain, the schema. So we go back to the schema, and we say, okay, maybe I can use some tools to take the text and extract information from the text. So taking unstructured data and outputting a structure from the text, actually. So let's say we will start with, I want to find persons in the text. So I create a person in my knowledge graph here. And the person must have a name. Okay? And then I can create a relationship, okay, between a news that mentions a person in the news. This is my new schema, and I will do the same for organizations, for example. Organization. And mentions organization. So how we are going to do this? So we're going to use a tooling that is doing actually natural language processing. So how does it work, really, is you give some text and it returns new things that he knows about the text. So for example, for this phrase, the French President Macron landed in Madrid for his courtesy visit in Spain. The software will return us that French is a nationality, President is a title, Macron is a person, Madrid is a city, Spain is a country. So it will give us a list structured that we can use to create new nodes and relationships with our graph. Okay? So if we take the same mental path with our graph, we go back to our knowledge graph, and I'm just going to delete the data to be sure. So if we look back at how the part of the graph that we could actually create from the data originally, here is in blue, all right? So this represents what we could take from the structured data and create nodes and relationship. So this is in blue. So really the exercise is to be able to create those relationships, to define how to create them by using natural language processing. So it's the next step in the application. So we say, okay, I want to create those relationships into my graph, mentions person. And to be able to do this, I will analyze the text of the news. All right? I will use default English natural language processing engine. And I want him to extract person from the text. And they will become the mentions of the person. So if we take this text, no, not that one, Emmanuel Macron here, it will become the name on the person node. Okay? So I add it, and I do the same for the organization. So I say, okay, for creating this relationship, I will analyze the text in English, extracting organization, mentions, and those mentions become organization nodes with a name property into the graph. All right? So we have, this is what we can do with structured data. This is what we can do by using natural language processing. I will import, again, the graph. Okay. It's always a stress moment. And so we can see that now the graph has become a bit more interesting, right? So we could extract from 2 nodes 23 person names and 3 organizations' names. And now if we actually see the graph that we have previously, we have those 2 nodes. But the real interesting aspect is that now they are connected. They have connections between them because this news and this news mentions the same person. And I can show even more. This becomes a graph like this. We have news and the enrichment of the text that appears as nodes in the relationship into the graph. And here we have only 2 documents. So you can imagine if you have thousands, 100,000, 1,000,000 documents, the graph that can be constructed from this. This is another example on Twitter, for example. So you can see once you can extract persons, organizations, locations from tweets, for example, simple tweets, I mean, this is 1,600 tweets, so this is nothing. The graphs becomes very interesting just by being able to create new relationships and nodes. All right. Now there is this is easy because you use tools that are trained on Wikipedia, DBpedia, Wikidata, news feed on the web. So it's very easy to extract persons, locations, and organizations, for example. It's very easy. So there is always some problems because it's very based on linguistics, grammar. So, but, I mean, you can find this for free on the web. But in 99% of the use case, you don't want to extract only persons, right? You want to extract things specific to your domain. Money, financial rounds, funding rounds, sorry, name of technologies, things like this. So we actually provide a tool that helps organizations annotate new data. So here is very simple text that is taken from this news, actually here, from this TechCrunch article. And actually you can see that it's very interesting, everything that you can annotate in the text, that this is an organization that develops a technology that receive a funding, that receive some money from a funding perspective. And actually here, the same organization competes with another organization. So, and the goal is to provide not 1, but 200, 300 documents, for example, with examples, and try to really create new capabilities in your organization for being able to create, because everything you see here will become nodes and relationships into your graph. Because the language is a graph. If I take the same text here, but I add more things, you will see that actually the language itself is a graph. The grammar of English and any language, Spanish, Arabic, whatever, is actually a graph. It's a dependency between words, and the words have additional labels to describe additional information. All right. Now, in base of action, it is really cool. We can visualize the graph. We can search. Woohoo. So I can open the graph here and search for Emmanuel Macron, and then double-click, and it will show new nodes and relationship. I can even double-click that one. And the problem most of organizations face is that they will arrive to the point of visualization. It's nice generally it makes a very cool effect because graphs are news to some organization. Seeing the connections, it will reveal new information on new connections that you didn't know. Oh, this person is connected to that person. It's crazy how then you can see it. But at the end, you want to be able to be more efficient or do something that is not provided by the product on the market, for example. And so we provide some capabilities, but then our customers ask, okay, can I do this? Can I do this? Can I do this? So we can say, I don't want to maintain code for you in my product, right? So we can say no, no, no. So, or we can say yes, yes, yes. And then we have a team of developers very angry. So we arrived with another solution. How can you modify the platform without touching our code? How can we let you create new features without us maintaining this technical depth in our software? So this is what we call, very fancy, knowledge graph actions. What are actions? They are actually things that you can add in the visualization. You describe them in a small JSON. You can even create a cipher. So you saw some cipher queries from Max before. You can even do this in cipher. You just store the actions in the database. You can do it. So let's say that our goal today is, here I have my search bar. Oh, wait. I will first delete the action, okay? Because you saw nothing. Here, there is nothing except that you can click, you can display person, organization, or news, or the relationships. So the goal is that I want to add something here that can do something for me. So let's say I want to have an input, a form, where I can start typing the name of a person, and with autocomplete, it will show me your options. And when I click, I want to show the person and all the surrounding graph, okay? So this is what we will do. So we will create an action here with an ID. And this action has input parameters. So when we define this, it has to show a form to the user that he has to fill in. And we say, okay, he has to select a person from a autocomplete. And when he selected the person, it will execute this cipher query. So it will find the person, find the news mentioning him, and the other persons that are mentioned by the same news he is mentioned in. Okay? So we will just copy this and go to the Neo4j browser and create a new action. All right? Now we refresh our browser because we have to refresh. And we have something here. Global actions. Global means that you can execute the action without having to select a node or relationship. Global, local. The name of the action that was defined in the JSON is show me ecosystem of a person. And when I click, it asks me, select a person. So I can start typing MA, and then it will find all the persons starting with MA. And I click one, and I submit. It will find Emmanuel Macron, somewhere here. Find the news. So it will execute, actually, the cipher query that we define here, and return the graph, the new graph, actually. Okay? So this is one type of action. Now I want to say you're not limited to execute cipher. You can even call an API that can connect to your CRM, for example. You can call weather information, whatever. Everything that you can do with Cypher or Epoch, or even writing your own Python application that will serve as returning the information for the action, fine. Now I will take another graph, which is a supply chain, fictitious graph. So we have products, order of products, countries, and products located in a warehouse. And we created a set of action. So here I want to right-click on a product and say, show me the stock of this product, or show me actually the demand of this product over the months, for example. Same thing, we create here an action that can return a chart, for example. So it's the same. The cipher is a bit more verbose, but so it's already created. So I will display the product here. And I can say, okay, show the demand for this product. And I can display a chart. Okay? Amazing. Now we're going to make something more complex. So there is this new information that is returned. But the user still has to know the data. Maybe we want to do something more complex, or giving hints to the user based on rules, based on information that is in the graph. So for this, there is an example. I mean, I want to take a product, I want to right-click and say, ship this product to this country. And then it should show me an information that I cannot ship this product to this country because it comes from a specific warehouse, for example. So actually the graph will exist because this product has been shipped from another warehouse to this country. But you need to show the user that it's not possible. So, same thing. Oh, I will come after. We create an action where we have to right-click on a product, select the country. It will execute the cipher and return information. So, let's go here, product. I hope it's the good one. So I can say ship product to Germany, for example. And it finds a path from this product to Germany. However, there is a small insight happening here that tells me the stock is not sufficient for shipping this product to Germany. The insight, this is what we call, hold on, knowledge graph insight. So knowledge graph actions, knowledge graph insight. And I can go to the insight, and it shows me that it's forbidden. All right? So we can also return more information. So if we click, it will pop up more information. But so far, the people didn't tell me why the stock is insufficient. So I know that I cannot ship this product, actually. Right. For the chart, I want to mention that we found a very interesting way of doing this. That, of course, we don't want to create new code in our software to say, now you can return a chart with bars. And then we have to create ourselves a new plugin. Now you can return a chart with a pie chart, for example. So we actually use a library where we're using the same grammar. So from the cipher, by just returning, clicking on this and checking what type, what format you have to return, we can actually automatically support all those charts returned from the cipher, actually. So we can display all those charts by default without having to write too much code ourselves. We want you to write code. So, of course, we can assist you. All right? Okay, so this is good. I showed you a demo where everything was working, right? However, in, let's say, 80% of the time, people expect magic. I'm not a magician, but and this is where the problem for the enterprise comes, is when they believe too much in this artificial intelligence magic, that it will solve all your problems. Also, there is a thing with artificial intelligence is that, I mean, I'm an engineer, so there is a cool quote recently that on Twitter who says, when it's written in Python, it's a machine learning. When it's written in PowerPoint, it's artificial intelligence. Right? Nobody get it? No? So I mean, natural language processing is superb. You can do amazing things. But you need to understand language. This is why you need also, I mean, people telling you we have the product that will solve your problem. It will automatically fine-tune. You can pass any text. I want to work for them, really, because I never saw this. I will give you a very practical example. So, I have this text. I have a language. A 30-inch piece of wood laying in the back of my truck. All right? So if we come back here, sorry. It's not that one. If we come back here, there is something that you need to know is that, for example, here there is the end of the sentence. You cannot say, hey, this is my entity. Actually, we cannot even do in our software. Because an entity cannot be on two sentences, right? It's not possible. And here, because the natural language processing, in natural language processing there is language. Sometimes it can treat this small point here as a sentence separator. So it means that you will never be able to understand 32-inch. Because for him, it's two sentences and not one sentence. And this is a huge problem, right? Because, I mean, once you want to add relationship in the same sentence, a different sentence, it actually messes up all your software. So those are the things that you need to know. I mean, not the business people, but the people, I mean, not believing all the promises, because this is one example. Example with parentheses, slash, things like this. There are millions of them. So this is why you would need always to be assisted by people knowing how language, how natural language processing software will behave based on your data. Right? I can give you another example. If we take Reuters News, for example, it starts always like this. Reuters. Google announced the acquisition of eBay. Let's get crazy. They have money. All right? So, here, named entities. Reuters is an organization. But if you think you will take this new information and you will put it in your graph, what will happen if, for example, your source of data is Reuters? You will have one Reuters node, and it will be the most important node in your domain, because it's connected with all the news. How important is this Reuters as a node in your domain? No. Second example, I cannot show with this, but let's say that we want to find relationships between the entities. So we want to find a relationship between Reuters and Google, between Reuters and eBay, between Google and eBay. So based on the model we have trained here, for example, who is investing in what company, for example? Well, this Reuters and eBay is a perfectly valid combination, actually, because the text inside is valid, I mean, based on the examples you've given. So you will arrive with a set of information that is irrelevant because it will create automatically in your graph that Reuters acquired eBay. But also Google acquired eBay because, let's say, the prediction score is 92%. Right? So you will actually make your new knowledge graph garbage. So this is why you need to understand this, that there will be always preparation and check, and there is no thing that can solve those solutions except humans. All right. I think I'm done, actually. Well, let's do it. Thank you. We don't take questions?
You want to take questions?
I don't know. $5 the question, right? Okay. $5 the question. Who? Yes.
How do you solve the things with the context and slang, for example?
What?
Context and
Context?
slang. How do you solve?
Context or emoticons or these kind of things.
Multicons.
Emoticons?
Emoticons. Yeah, I mean, emoticons is part of our language nowadays. It's true. So you have to turn to other type of NLP software. So there are models trained for understanding emoticons, but it's mostly based for sentiment analysis, for example, rather than understanding what this emoticon means, but it exists, for example. So there are software out there trained on emoticons in text, for example, yes. So, but it's not really a use case we see often in the industry. So, $5. Okay. Yes? Like to do this? We use artificial intelligence software, so Java and Python. So yeah. And JavaScript also. Vue.js. Yep. All right, thank you very much. Fika.